Good afternoon, everyone, and welcome to this year's virtual Soapbox Science Milton Keynes event. I'm Dr. Barbara Kunz from the Open University, and I lead you through this afternoon's session. Soapbox Science has been created as an outreach platform to bring science to the street and general public, as well as to promote women and non-binary scientists in STEM and highlight the fantastic research they are doing. We are very excited to have the first 6 of our 12 amazing scientists speaking today, telling you about the research they are doing. On Saturday, we will have the second part of our event with the remaining 6 speakers at the same time and platforms as today. So make sure to come along to that session as well if you can, or watch the recording afterwards. Each speaker will give a 5-minute presentation where they introduce themselves and their research. After that, there will be 5 minutes of time for questions. So if you have any questions for the speakers regarding their work or themselves as scientists, please make sure to type in the questions into the chat or comments, and we will pick them up during the Q&A. We might not get to all of the questions during the event, or you have a question after the speaker's time slot. Don't worry, just type in your question. Make sure that you mention who the question is for, and we will pass it on to the speaker, and they will answer them in a blog post that will be published on our homepage, which will be linked in the video below. So make sure to check this out in a couple of days, and we will also announce this on our social media channels. Our first speaker today is Dr. Iveta Monti. She is a researcher in human-robot interaction at Cranfield University.
Hello, my name is Iveta, and I'm a researcher at Cranfield University, as Barbara introduced. So although my PhD was in psychology, my work differs from what normally people imagine psychologists are doing. I'm investigating how humans and robots could coexist in the future. So although some of my days I spend in the office in front of computer, just doing the usual things. Other days I spend actually in laboratories and in factories investigating how people work with robots. That sounds really cool, and I really do like my job. So for example, I would be looking how people work with manufacturing type of robots, like the one behind me, or what our users need from humanoid robots used for entertainment or education, and even looking how autonomous vehicles should behave that anybody of us would be happy to jump in and have that experience of driverless car. So just to give you an example, this is Myro. Myro is a companion robot. At the moment, he was very loud and noisy, so I had to turn it off. But Myro indicates its moods by letting his back either red or green or any other color, just to say how it's feeling. Myro has cameras in eyes, and if I would put Myro on the floor, he would follow me wherever I'm going and make a lot of cute noises, just indicate that he wants pats and attention and just needs some human love. So this type of robots, like Myro, could be used in pet therapy in the environments where actual pets are not allowed, for example, like in hospitals, or they could be used as companions for elderly people when people can't anymore take care of a real cat or dog. So when I start research, interacting with participants, with general public, I normally ask, so how do they imagine they would interact with Myro? Where they would keep it, what behavior they want it to show, or even starting, do they think Myro is a girl or a boy, and what name they would give it? The most interesting answers probably come from children when they say that, yes, Myro can be their friend, they would be happy to interact, but still at night, they would put Myro somewhere in the box and lock it, or in the wardrobe, because they don't want it to wander around the house. So what do I find in my research is that people have they are either very excited about robots, or they are cautious and wary. And this is not surprising, because normally it depends what they have in mind when they say robot. Is it somebody cute, like Myro, or is it something more cold and purpose-built, like Komau robot behind me? And those initial attitudes are very important because they can determine actually, will this new technology be accepted and used to its full potential, or it will be rejected and put somewhere in the corner? The project I'm working at the moment, Sherlock, is looking exactly at that in manufacturing environment. So it's looking how operators, what are operators' needs and requirements from industrial type robots like the one behind me. So what speed the robot needs to move, what kind of behavior it needs to show, does the movements need to be like human or can it be more artificial? Does robot need to adjust its behavior on different users? So all those questions feed how eager people will be while interacting with this type of technology. So of course, it's a big machine, it can feel threatening and people feel very wary around it. But on the other hand, it has huge potential benefits starting from safety. So if these type of robots would do dangerous tasks like welding or drilling or repetitive and monotonous tasks, more strenuous tasks like riveting, it can increase physical comfort for the operator. At the same time, there are lots of psychological benefits. So if people interacting with that robot, they feel more confident about technology, they feel less time pressure on their tasks, they are happier while working in their position, and even they would become from assembly line worker to robot operator. So straight away, it offers those upskilling opportunities. So to sum up, working in this field, my task is to see what people need and require from robots, that they would be happy interacting with them and they would use that. It's not an easy task, but it's very important in order to ensure that the new developing technology achieves its full potential. So the answer to the question, what future holds for humans and robots, is still under development, and it depends on each of us. So I encourage everybody to join that discussion between scientists and technology developers and just say, what do you need from robots? Thank you.
Thanks, Iveta, for this interesting presentation. I'm now going to hand over to Sophia to ask you some questions.
Thank you, Barbara, and thanks a lot, Iveta, for this fascinating talk. I think the first question that we have from the chat is that, now in Milton Keynes, we have these Starship robots that deliver your shopping to your home. So how does your research, is your research involved in that, and what kind of interactions we can have between humans and these type of robots we can find in the street?
So I'm personally not involved in that research, but it's very interesting point actually what all this Starship project can show us, because as I mentioned, some people are so excited seeing those delivery robots dashing on the roads and crossing the streets, but on the other hand, you also see some of the robots being abused, like the antennas are bent and everything. So just thinking, what is the reason behind that? So obviously anxiety, being afraid of the technology, not wanting it on our streets, but what we could do to make people more welcoming towards the technology. Would naming each of that robots, just maybe John or whatever, Fluffy, would make it more friendly and approachable to people, that they wouldn't want to abuse it and they would feel definitely happy and confident that it's approaching their house.
Great. And do you think our perception or our attitude towards robots has changed over the years? Are we getting more familiar with them now? What have you found?
I think it is. Definitely people are getting more familiar. And I think it's very much dependent on the context and what kind of robot we are talking about. Because when I'm doing work in factories with operators, and they are really still influenced by the media saying, oh, the robot injured so many operators, or it goes rogue and goes Terminator form. But on the other hand, once they get to experience the robot, and more of them get to experience the robot, they just start to understand, oh, okay, so it's has the limitations, but also those are the benefits, and I can embrace the benefits while I'm aware of limitations. I'm just more trusting towards robots. At the same time, general population, I think it's getting a bit more normalized from very hype opinions that robots, those amazing things that will do everything. It's coming down to, yeah, they are amazing, they're really cool, but they are not exactly how they show in the movies.
Exactly.
So, yeah.
Great. And how soon do you think robots might become commonplace in our lives?
That's another very interesting question, because I think we already see them almost as a commonplace. Well, definitely in Milton Keynes, we can see them every day. If you're working on production line, even from the 70s, you could see the robots being segregated. Now they are just coming out of their cells, out of their cages, and working closer to the human being. But that future vision that robots are interacting almost like humans, they have that natural speech and they have their own behavior. I think we will need to wait quite a bit to that. So it's still technology, is still being developed and programmed by humans, and it still has the limitations of that. So it's just cool.
That's great. And one quick, a bit more personal question. Which parts of your job do you enjoy the most?
I love interacting with the general public and in particular children, and just seeing how they view that new technology, because they are less influenced by media, by negative or even positive articles, and just comes so natural for them and so from their heart. It's really exciting to see this.
It's fantastic. I don't know if we have, Barbara, time for one last question.
I think we have to move on, I think. But be sure that I'm sure there were some more questions, and that Iveta will answer them in a blog post, as I said. So even if your question hasn't been asked, there will be an answer to that. And I think in terms of timekeeping, we have to move on to the second speaker of today, which is Dr. Jan Colley, a lecturer in cybersecurity at the Open University. Over to you, Jan.
Hi, I'm Jan Colley, and I'm a digital detective. Well, I don't really need the hat. I do quite often need a magnifying glass, but even more, I need screwdrivers of various sorts. Well, why is that? I'm a digital forensics and cybersecurity specialist, and that means I spend a lot of time not only opening up computers and mobile phones, but sifting through other people's computers and mobile phones and other devices, either trying to find out what criminals have been up to or tracking down sources of hack attacks and data theft. I'm also a scientist, as you've just heard. I'm a lecturer in cybersecurity at the Open University. And when I'm not writing materials for our courses, I'm working on my research. A little bit more about that in a moment. First, I'm here to talk about digital secrets. So that's the secrets that your gadgets know about you and the secrets that you give away every day. First, the gadgets. Imagine you have a special best friend, someone you know really well and trust, someone you think you can share anything with, someone you believe will never let you down. Wouldn't it just be awful if you suddenly found out that that friend was quietly spreading your most intimate secrets around? Yeah, that would be awful. But that is exactly what your digital friends are doing all the time. You've told them your secrets, name, address, passwords, browsing habits, favorite music, and much, much more. And they busily transmit that information day and night whenever you're connected to a network. Well, you do need to shop, do your banking, catch up on social media, maybe make a date, yeah? That information is very valuable to people who want to sell you things, as you'll find when adverts for something you've been searching for recently turn up when you're browsing your social media. It's equally valuable to hackers, and that's why they lurk in the shadows trying to steal it. Now, some of the research I'm involved in centers around making gadgets more secure. Secure when they're in your home and secure when they're transmitting information. This is important for everyone, but imagine if you had a medical condition, something that needed you to wear a device that monitors when you need urgent help. Again, these devices are also passing vital personal information over a network. And unfortunately, that information is highly susceptible to both unintentional leakage and completely intentional hacking. That's why research like this is so important. Another big research interest of mine is hacking the human, or put more politely, the human side of cybersecurity. And this is where you, my friend, come in. Many studies show that no matter how secure technology is, humans have a natural knack of making it less secure. Why? Well, remember that I said that gadgets chatter all the time? And no surprise, humans chatter all the time too. WhatsApp, Tumblr, Facebook, Twitter, Instagram, in fact, over any and every messaging app and social network. We exchange messages, photos, videos, all sorts of stuff. And that stuff gives away a huge amount of personal detail, not just to our friends, but to our hacker enemies too. So we seriously need to protect ourselves online. How do we do that? Well, there's two simple ways to start protecting yourself better, like this. Zip it and lock it. Don't tell anyone you're going on holiday for a week, or that you're already on holiday and away for however long on a public forum. Burglars are on social media too. Remember, if someone can discover where you live, they can locate your house on Google Maps and figure out easy entry points and quick getaway routes. Plus, if they know you're away, they'll know how long they've got to carry out a break-in, completely undisturbed. Another thing, don't give away personal information that would help someone guess your passwords. Things like pets' names, your nickname, date of birth, favourite pop star, football club, perhaps your best centre forward. And that brings me to lock it. Do use passwords on all your accounts. Use different passwords and good passwords. So again, nothing that can be easily guessed. Make them strong and make them long. There are free password manager apps out there that will not only help you to devise multiple secure passwords, but also keep them all nicely locked up for you. All you'll need is to make up and remember one strong and long password to unlock your password safe. I promise you it's simple, so there's no excuse. If there's one piece of information I'd like you to take away from this talk, it's this. Think twice before you post, and don't give out personal details that could be used to scam you or steal your identity. For instance, people phoning you up, pretending to be your bank, where will they get familiar details from? Your social media interactions or anything else they've been able to get your details off. Okay? Thank you for watching. Stay safe and stay secure.
Thanks, Jan, for this really, I guess, timely and very important topic. Are there any questions?
Yes, really interesting talk. Thank you very much. So how easy is it to delete information from our computer and mobile devices?
Unless you really know what you're doing, it's very, very difficult indeed, because computers keep multiple copies of all your data. So let's say you've typed a document, and I quite often say to people, how many copies of that document do you think? You've just made the one as far as you're concerned. How many of those copies, how many do you think are on your computer? People say, oh, maybe 2 or 3. It's probably more like 15 actually, in various ways, shapes and forms. And they'll be scattered all over the computer. If it's a computer hard disk. Obviously, if it's your mobile phones also have memory on board. So it sort of gets sprayed all over the show. So even if you think you go delete, 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 and that's just cleaned everything up, somebody like me is definitely going to be able to find that out. And even if you've used professional wiping software, which you can get on the internet, usually those leave tracks behind as well. So if I find lots of zeros in places where data ought to be, And I know perfectly well that somebody's used a professional white pig thing, and that doesn't look too good in a court report.
Oh, scary.
Yes, it is.
So can a digital forensics investigator look at anyone's computer or mobile device then?
You can't just randomly take people's computers and mobile phones. Sometimes people phone me up and say, oh, I think, my partner's been doing something and I don't like, or maybe somebody I live with, somebody in the same house I share a house with, I think they've been doing something I think is bad or illegal. Will you have a look? And I have to say, no, that is illegal. You have to have specific, you have to have the specific authority of the person who owns the machine or the mobile phone. The only other way you can do it, of course, if you've been engaged as an expert witness, as I frequently am, and so perhaps you're getting evidence the police have already looked at, then obviously you've got permission because the solicitor has instructed you to look at their client's machine or mobile phone or whatever it is. Or if it's a corporate, the same thing, the machine belongs to them, that's fine. But no, you can't randomly just say, oh yeah, that's okay, I'll come around and have a look at that. You've been in the most ghastly trouble.
Good to hear. We have a question from Carol. The question comes from Facebook. So Carol is asking, okay, how can we invite robots into our home, like Iveta was suggesting previously, but still make sure we keep our home data secure and private? So I guess lots of people are afraid of iRobot scenarios. So what's your suggestion? Can we still use technology and robots in new gadgets while keeping our data safe?
That's a big one, and that's part of, there's a lot of research going into that at the moment. All these gadgets that we have, as you know, it's called the Internet of Things. So all these cool little devices, the personal assistants, you can call them, that you just talk to and say, oh, put tissues on my shopping list, things of that nature. The trouble with a lot of these devices, perhaps not so much the proprietary ones, I won't name names, but the ones that we know best, have probably got better and encrypted passwords on them now. But in times past, things would arrive up. For instance, there used to be a smart kettle that you could put on your network, and that would keep your password, your network password, in what we call in the clear, so not encrypted. So anybody could hack into that, pinch your password and get all over your network. So it's a very difficult problem and something that researchers are looking at. So the best thing is to have a very secure network password. So your Wi-Fi network or your hardwired network that comes into your home, make sure that you put a really good password on it. Don't just keep the one the manufacturer puts on it. And don't use admin or password, don't use stupid stuff. Like I said, think of a long word, a long phrase is the best, a really long phrase that you're not going to forget, and then put some uppers and lowers and change some characters, but make sure you're going to remember that. And don't make it obvious, because other people coming into your house might be able to just guess that. And the next thing, they're on your network. And that's the best we can do at the moment. We are trying to improve encryption on these useful gadgets that we have in our home, so to prevent this kind of security problem.
That's a great advice. Thank you.
You're welcome.
Thanks. Yeah, that was really interesting and insightful, and thanks for your research. I guess that really helps to make things more secure. We will have now our next speaker, which is Paula which is Paula Nakoli-Klinka. She's from Greenfield University, and she's a PhD researcher in energy and power.
The robots are taking over. So when you think of robots, what's the first thing that comes to mind? Is it cyborgs, the movie The Terminator, or even iRobot? Well, that's a general consensus when it comes to picturing what a robot is. But when we really think about it, a robot is just a machine that is capable of carrying out a bunch of complicated actions automatically and faster than we can. So technically speaking, whilst they're not exactly the same, you could consider a robot similar to a computer, laptop, or even your smartphone. So when I say the robots are taking over, don't worry, I'm not talking World War III, humans versus robots. I'm talking about how we can use artificial intelligence, AI, or machine learning to help us complete tasks that are time-consuming and costly. So in the science world, this means letting the robots do the experiments for us. Well, not really, but I'll explain this further. I'm Paula, and I'm a PhD researcher at Cranfield University. And my topic of interest is using AI to help optimize the process of developing clean energy. Artificial intelligence is common in almost every kind of industry, and the use of machine learning is being applied to accelerate, automate, validate loads of processes faster than we can. Another rapidly emerging technology is hydrogen energy, H2. And combined with capturing carbon dioxide, this process is called calcium looping. In this process, a calcium-based sorbent is used to absorb carbon dioxide that is produced from reacting methane or natural gas with steam. And this leads to higher quantities of hydrogen. And this also reduces the number one greenhouse gas emission, CO2. Hydrogen energy is a great replacement for fossil fuels, such as coal or oil, because it doesn't release harmful chemicals into our environment. And this is great because it helps reduce the rise in the Earth's surface temperature, and it helps mitigate the worst effects from climate change. And we definitely need that right now, don't we? So this all sounds great, right? But there are some obstacles in upscaling the process of hydrogen production. The main obstacle is not knowing the optimal material that maintains a good carbon dioxide capture as time progresses. As I mentioned before, the calcium looping process needs a material that can absorb and remove carbon dioxide. Adsorption is when a substance, usually a gas, forms a thin layer onto the surface of another material, so essentially getting carbon dioxide to stick to the surface of another material, and this material, the sorbent, needs to have certain properties to allow carbon dioxide to continuously be absorbed without the sorbent losing its properties, so it can work over and over and over again. A way to overcome the obstacle of finding the optimal sorbent is to test loads of materials in the lab and to record the carbon capture capacity after loads of cycles, so essentially a trial and error process. But this isn't very efficient, is it? So a solution is to get a bit of help from our friends, the robots, or artificial intelligence. We can use AI to help screen and predict lots of materials' behavior that are optimal for this process and save us a lot of time. There are loads of methods that can be used to achieve lots of different outputs. An example is getting results from previously tested materials from other studies and then coding or programming a computer to then find patterns in the output data based on things like the periodic table or experimental conditions. And then we allow the computer to predict the output of other untested materials. The best way to obtain accurate results is if you feed the robot or give the computer a lot of data. That way it has loads of information to base its predictions on. So I hope that doesn't make robots sound scary. This isn't some kind of mission to wipe out the humans. It's just using maths, science, statistics, data science, computer science, and all that good stuff to predict other outputs of data. That sounds a little bit boring now, doesn't it? You know what? Let's go back to the robots taking over. But if coding or computer science is something that you enjoy, then this is a topic that you would definitely be great at. So I say have a look into it. You just might be the next Elon Musk. Thank you for listening. I'll take any questions.
Great. Thanks, Paula, for joining us today and talking about your research. Let's see who has any questions. I'm sure there are some.
Yes, we do have some questions. Thanks a lot, Paula. It's quite an exciting subject to research. So I was just curious, how many materials, how many sorbents are you able to screen for their ability to capture CO2 using the machine learning predictions?
That is genuinely infinite when using a machine learning algorithm to predict it. Obviously, in a lab, it will take you months, years to test, let's say 500 materials, because you have to synthesize them, test them into the reactor and get an output. But you can chuck them the results into a machine learning algorithm and it can predict the output. One thing I will say is that you would probably have to validate the results afterwards. So whilst it can screen infinite amounts of materials, if you get good results out of it, you can say, yes, okay, this is the material that I would like to take forward. And then you'd have to do an experiment to validate whether or not, yes, the computer did predict it right. So the possibilities are endless with machine learning.
Wow, exciting. So how do you see the machine learning technology changing in the future?
That's a good question. I think the two speakers before me actually spoke a lot about how robots or machine learning will go on in the future. I think it will honestly be introduced into loads more different novel applications, ones that we can't even fathom right now, because let's say what we're doing right now, 10, 15 years ago, we wouldn't have thought, yeah, we're gonna, have Teslas, we're gonna have, like the Milton Keynes shopping stuff. So I think it's gonna go into loads more applications. Some might say that it might be a bad thing because it's gonna wipe out the, manual labor and things like that. But I do think it could be a great thing, and I think it will work side by side as opposed to, like I say, taking over.
So yeah, that's interesting to hear. You did mention that this type of technology, I mean, the research you do is to help explore better hydrogen energy. We hear a lot about renewable energies at the moment, like solar and wind power. Why is hydrogen energy so important and is being explored? How does it compare with the others?
Well, I think there's loads of pros about hydrogen energy. It's you can produce it from many different ways, many different, like the process I described is just one of many different processes that you can produce hydrogen from. It's very efficient, that when you do get hydrogen energy out of it, it's very efficient, and it's clean, it's non-toxic, so that's great. When it comes to solar and wind, for example, as we can see, the climate is very unpredictable, and it's down to obviously human actions. So we could have a sunny day one day and like a ridiculously windy day another day. So then in terms of like the startup costs as well and the operational costs of solar and wind energy, I don't think they compare to hydrogen. So once we can perfect a very sufficient way of like producing hydrogen, I do think that it would like overtake solar and wind like vastly. So I think that's why it's like picking up really quickly right now. And it's because we've got great technology in terms of machine learning to help us like upscale it quick.
Yeah, it's great to have any tool in our toolbox to combat climate change.
Exactly, right? We definitely need that, yeah. So
I'm going to ask, which is the part of your job that you enjoy doing the most?
I enjoy the coding the most. So you could work away like at a code for days, hours or days. Hours is like very successful, or days is like an average. And then when you get a working code at the end of it, it's like, it's like Christmas, and all you had to do is like move a colon just one space over. It's just so satisfying when you just get like a working code. So that's my favorite part of my role.
That's fantastic. I'm sure lots of people can relate to that.
Yeah.
Lots of people watching on Facebook and YouTube. So thank you very much.
Thank you.
It was great to hear all about it, and good luck with the rest of your project.
Thank you.
Yeah, thanks for taking the time to answer the questions. And now we move on to our next speaker, which is Tizzy Huntington, a chemical engineering PhD student at Cranfield University.
Hi, I'm Victoria Huntington. Everyone calls me Tizzy though. I'm a PhD student at Cranfield studying in the Regenerators project, which is sponsored by Interreg in the European Regional Development Fund. Mine's a bit different to everyone else. I concentrate on metals, specifically critical metals. We all use, need, and have them. We all use critical metals without even realizing. We're all using them right now in our phones, our computers, our laptops. We're using to stream this seminar. But what actually are critical metals? They are used in technology. The supply is riskful, and there's no alternatives for them. So basically, we all need them, but we can't always have them. Let's take lithium, for example. Lithium is fundamental for battery production. In 2015, battery demand was 15%, but because there's been a massive push for electric vehicles, energy storage, and electric bikes, battery demand will increase to 58% by 2025. But where do we get lithium from? Predominantly Chile and Argentina, where they use salt lakes, salt deserts, or salars. These salars use underground aquifers with concentrated lithium in. They pump the water up to the surface where the water evaporates, leaving behind a lithium-rich salt, which is then processed and then goes off to the different things, predominantly batteries. The biggest salar in Chile is called the Salar de Atacama. This uses 65% of the region's water. Not only this, when they are doing their processes, they're also contaminating little streams which farmers and locals are using. So they're taking 65% of the region's water and also contaminating what they leave behind, leaving very little water. On the other side of the world, in Australia, they use these open cast or production techniques. We've all seen them. They're big scars, permanent scars on the environment. They also destroy the diversity. They also erode all the soil and contaminate the water, surface water, and the soil. This sounds like a lot of unnecessary environmental damage. Surely there must be another way. This is where I'm coming in, using green solvents. What are green solvents? What do? They minimize environmental damage, which would have happened if we were using other solvents. They are derived from agricultural crop processes. In my PhD, I'm focusing on two types of green solvents, chelating agents and deep eutectic solvents. Now, chelating agents, I'm using GLDA, EDDS, and NTA. That's a lot of letters that don't mean a lot to you. So what actually does it mean? Basically, chelating agents are compounds which bind to metal ions to form ring-like complexes, which are called chelates. Chelators in the past have focused on copper and iron, but previous studies have said that they can be used for all critical metals. Now, deep eutectic solvents, they've been described as the most promising green solvent in all of green chemistry. They're a class of ionic fluid, and they are a mixture of Lewis and Bronsted acid and bases. Eutectic means a substance which has a lower melting and freezing point than that of its individual constituents. Now, chelating agents are inexpensive, they have high selectivity, and have a large absorption capacity. Eutectic solvents, on the other hand, are also inexpensive. They also have high selectivity and high absorbance, but they can be infinitely recycled, infinitely reused, and they're also non-toxic and biodegradable. It's the answer to all of our problems. So actually, what difference does this make? Where can we use them? What does this mean for me? There are three main benefits. There's less damage to the environment, it's more economic, and it saves on valuable raw material. So let's get into environmental damage. We've previously talked about the salars and the open cast mines in Australia and the damage it can cause. If we can use these green solvents on other sources, possibly old mines, old landfills, and other industrial sites, this will reduce our dependency on these salars and open cast mines, alleviating all the associated environmental damages. Also, everything decided is dependent on money. Using these ways, we use less energy. Less energy reduces our costs. However, using less energy also has a knock-on effect. Less energy is used, fewer greenhouse gas emitted. Fewer greenhouse gas emissions means reduced global warming. Everyone's a winner. So let's recycle our metals into the economy, keeping our metals into use, and let's use green solvents and keep everything going in the circular economy. That's it.
Thank you. That was great. That sounds like really interesting research. And I'm sure many people have questions about that. Jill, do you want to ask some questions?
Yeah, sure. Yeah, great and really interesting talk. Thank you very much. So I have a question here from Becky. Becky's asked on YouTube, hi there, I have a student at Watling Academy who is interested in how Victoria first got into her career.
So I did a master's in environmental science at Bangor University, which was the best place to do environmental science for me. From there I went rogue and I worked in construction for a little bit and saw the other side, and I was like, this isn't for me, I'm destroying the environment, I'm not protecting it. So I decided to go back to my roots and further study what I did in my master's to increase my knowledge, and here I am.
Oh, Bangor's a great place. So on Facebook, Julia asks, can the technologies you talked about be used to recycle materials from devices too?
Yeah, so there's been extensive research on waste electrical material, which is massive. Yeah, so these chemicals can be used on those specifically, and it's dependent on what type of, like how the waste is eroded or how the waste is being stored. So it's specific per waste, but yeah, it's been extensively used on waste electricals.
Cool. So is there anything that we can do when we are recycling or when we're putting these materials to improve how that happens, how efficient that is, say?
So if you had a product like your phone, if your phone was broken, I would first say, can you just get it fixed? Like keep it in the cycle as long as you can. You don't need to throw it away. And if you do have to throw it away, I'd send it to like Music Magpie or something that can refurbish them so they're not just sent away. And then from there, if we had to send it back and it can't be fixed, it can't be refurbished, I'd send it away to the specific route, not just put it in my bin in the kitchen. Send it down the right route so it goes down the right avenue, so each bit of the phone can be recycled in the appropriate way.
Nice. So there's things that we can do at our end as well as to help you in your research and on that aim as well. How are we doing for time, Barbara? Do we have time for more questions? One more question.
One quick question.
Yeah. Okay. One quick question. Oh gosh. So obviously you talked internationally. Just how large is the scope for this in the UK?
So in the UK at the moment, Cornwall, they had a lot of tin mines in the past. They're using a lot of these green solvents in their old tin mines. It's proving very popular, and that's actually getting a lot of lithium, and that can meet, I think it was about 20% of the demand for lithium. I might be wrong there, but tin mines in Cornwall are very productive at the moment for lithium.
Perfect. And presumably that, yeah. Sorry.
Yeah, you can use that across the UK. And my project's focused on an old industrial steelworks site in Teesside. So if all around the UK there are possibilities.
Okay, much closer than South America. Thank you very much.
Yeah, great. That sounds good, and I guess it's always good to find like local places rather than far away places. So good luck with the research, and we look forward to hear maybe in the future from you.
Thank you.
Now we have our next speaker, which is Emily Swabby, a PhD researcher in paleontology at the Open University.
Hi everyone. Thank you, Barbara, for the introduction there. So I'm Emily, and today I want to talk to you about my PhD research, which is looking at the effects of the early Jurassic extreme environmental change on insects. What does that mean? Well, first we need to look at the present day. Insects are all around us and are the most diverse group of terrestrial organisms in the history of life. Now, these animals are extremely adaptable and form a vital part of almost every habitat on Earth. Insects help to pollinate plants, cycle nutrients, disperse seeds, and are also a major food source for many taxa. Now, astonishingly, there are 1.4 billion insects per person on this planet. In fact, current studies estimate that there are 6 million species of insects on Earth. However, only 20% of these insects have been described and named by science. So there's still a lot that we don't know about insects. Now, modern day climate change is significantly altering ecosystems and biodiversity at an unprecedented rate and scale, and is already triggering widespread species extinctions, with studies estimating that at least 1 million animal species are facing extinction in the coming decades, and sadly, approximately half of these will be insects. Now, it's thought that insects are highly vulnerable to the impacts and effects of climate change, and this is mainly due to the fact that their short life cycles are strongly influenced by temperature. Yet, despite their importance within ecosystems, research into the effects of current day climate change on insects remains unclear. However, through exploring past periods of extreme environmental change and essentially looking for clues within the fossil record as to how past insects have adapted to past climate change, we can better understand how modern day communities are being affected by global warming and what the future might hold for them. So, what past period of extreme environmental change are you studying? I hear you asking. Well, During the early Jurassic period, approximately 183 million years ago, when the dinosaurs were also roaming the Earth, there was a global event of extreme environmental change referred to as the Toarcian Oceanic Anoxic Event. Now, this event was characterized by a severe phase of global warming, where global temperatures rose by 7 to 10 degrees, and large volumes of CO2 were released into the oceans and atmosphere. And now this event also coincided with the mass extinction of both marine and terrestrial organisms. And so the geological record for this event contained several fossil insect beds, suggesting that insects must have been affected in some way by this environmental change. However, the link between these insect beds and this climatic change of the early Jurassic period has yet to be studied until now. So, as part of my PhD research, I'm in the process of studying and gathering information on every Toarcian insect, including specimens of fossil cockroaches, beetles, flies, dragonflies, and crickets from all around the world, including specimens found right here in the UK to those found way over in Australia. Now, part of my research also includes going to museums to take a closer look at these specimens, including the collections within the Natural History Museum, which I'm sure a lot of you will have visited. And it includes actually going into the field to see where these insects are coming from within the rocks. And that's in again, fieldwork localities in the UK and in Germany, for example. Now, once I've collated all of this information into what will be a very large yet useful database, I can then use this to analyze things like the abundance, composition, and variation of these insect communities during the Toarcian. Now, I also want to look at why these insects are seemingly only found within either 2 or 3 horizons within the Toarcian. Is this just how they were buried and preserved within the fossil record? Or does this environmental change cause some sort of mass mortality and essentially kill a lot of insects at once? Ultimately, I'm going to compare my insect data with environmental records, including things like elevated CO2 and temperature, which are also preserved in the geological record, to essentially build up a picture of what life was like for these insects and how exactly they were affected by the extreme environmental change of the early Jurassic period. Thank you everyone for listening.
Thank you, Emily. That sounds like a large inventory you're doing there.
Yes.
I'm sure there are questions about this fascinating topic.
Yeah, absolutely. Great talk. Thank you.
Thank you.
So again, we have a question via YouTube from Watling Academy. So Becky's asked on behalf of one of their students who would like to know how you go about preparing and preserving a fossilized insect.
Oh, that's a good question. So I think in terms of the preservation of the insects I'm looking at, most of them are actually 2D. So essentially during the process of fossilization, obviously the insect gets buried and the weight of the sediment on top of the organism essentially crushes it in this case. So what we're seeing, or what I'm seeing when I'm looking at these insects, is effectively a 2D film of what essentially is a squashed insect. And in the case of my project, a lot of these insects are actually isolated elements, whether that's isolated wings or legs. And this is because these insects must have been disarticulated and broken up prior to fossilization. But that's not always the case. I mean, sometimes, I've been looking at specimens that are beautifully preserved, just like a dragonfly is settled down on the ground and it's just remained perfectly preserved. And in some cases, like with a few of the beetles I'm looking at, so beetles are composed of hardened forewings called elytra, and they're really well preserved in the fossil record because they're a lot tougher than perhaps other insects would be. So you can even find those 3D preserved, which is fantastic.
I guess it's more readily we think about bones being scattered, but yeah, I wouldn't have necessarily thought about insects. That's really interesting. Thank you.
Yeah.
So another question that's come through again from YouTube from Namrata. Sorry if I've got that name wrong there, pronouncing that. With gardening, insects play a great role. Can you please explain something if your researchers included that in the study too?
Within gardening, did you say?
Yeah, so kind of that kind of role that that insects have, I guess.
Yeah, well, I think obviously, the ecosystems and habitats of insects are so important. And I think the thing to bear in mind about my research is I'm specifically focusing on temperature aspects that's affecting insects with the global warming. But like I said, these habitats are so important for insects. And that's, people automatically think with anthropogenic climate change, so human climate change, it's all about the temperature increase, when in fact things like habitat loss and deforestation, pollution, pesticides, they all play a significant part in the factors that are challenging these insects at the moment. However, I'm not really obviously looking into that. That's more of a anthropogenic, obviously what we're causing, unfortunately. Thankfully, 183 million years ago, there were no humans doing any danger.
Cool, that's brilliant. Thank you very much.
Thank you.
Great, yeah, thanks for taking the time to answer the question and about this fascinating topic. And yeah, learning that we think about fossils always in just one way, but there's more than one way. Yeah, great, definitely. Thanks. Thank you. Then we have, last but not least, our sixth speaker today is Manpreet Doot, a Cranfield University PhD researcher in aerospace manufacturing.
Okay. Hello, good afternoon, everyone. My name is Manpreet Doot, and I am currently a researcher at Cranfield University in aerospace manufacturing. So my project involves focusing on aircraft maintenance and how we could use the latest technology, state-of-the-art technology, to assist engineers in order to make inspection tasks much more easier for them to conduct. So just like a car that you would take into a garage for an MOT test or for a service check, the similar concept applies to an aircraft, however, to a much larger scale. So this is where you see the aircraft hangars at the airport, for example. So my project focuses on fighter jet aircraft, so just like this model over here. So my project focuses on the Eurofighter Typhoon, which is shaped just like this model over here. And you can see it is much more different in shape and size compared to your standard commercial aircraft that you would go traveling in. So my project focuses on fuel tank inspection. So just like your car, which you would take to the petrol station to fuel up, an aircraft has different types of fuel tanks which are located across the aircraft. So again, the locations of the fuel tanks would be within the wing structures and also in the center fuselage found across here. So my project focuses on wing fuel tank inspection, which of course is a very, very challenging task, which involves engineers to enter the fuel tank to conduct inspection. So they would have to enter through an entry over here and be able to crawl within the wing to reach the wing tip over here. So as you can imagine, it's very claustrophobic, it's very dark conditions, a lot of lighting is required, and the engineer would have to be wearing protective equipment in order to enter such a toxic environment. So you have to take into consideration the jet fuel vapor, for example, and the emissions that it releases, which is very detrimental to a person's health. So how can we use something like robotics? So this is just an example of a robot dog that you could see over here. So how could we use something like this as a basis to assist engineers to conduct inspections? So you could use something like this and have different types of sensors on board, a camera on board that would be able to crawl within the fuel tank and eliminate an engineer to enter the fuel tank themselves. So this, for example, something of this size would not be feasible for an aircraft fuel tank. We would need to develop and design something very small that would be able to carry all the electrical components and be able to maneuver around the complex structure of an aircraft. So as you may know, the basics of the aircraft structure include the spar structures and the rib structures. There will also be different types of wiring. There would be fuel transfer pipes. So it's a very challenging project. And how can we develop such a robotic system that would be able to overcome all these different types of structures? So my project is somewhat introducing an innovative robotic system design that would be able to enter the fuel tank, and the engineer would be able to remote control the robot system within the fuel tank. So this is just a plastic case of a robot system that I am designing, and you could see it's much more smaller than something like this. And it's more like a snake type of robot. So it's very narrow, very slim. The black sections would include the wheel hubs, which would allow the robot to move backwards and forwards. And the center system over here is a modulation system, which would allow the robot to bend, to turn, and also to move quite flexibly within the fuel tank. So it's a very challenging project because we have to be able to understand how can we add different types of electrical components on such a structure, taking into consideration the payload, the different types of sensors that would be added on to this, yet keep this sort of size. And this is very challenging. We have to take into consideration the different types of materials that we could also use, so that the robot within the wing fuel tank would not damage any sort of spar structures or leave any sort of scratch marks anywhere. So it involves a lot of tasks, and it's very multifaceted, and it's very challenging to achieve overall. However, this is just a starting point of my project, and my project is basically focusing on the mobile platform of the robot, and then somehow being able to develop a test rig, which we would be able to test the robot in once it's fully assembled with all the electrical components, and be able to analyze its movement, for example. So thank you very much, and I will be happy to take any questions.
Thank you, Manpreet. That sounds like a really challenging but very interesting and I guess very important task to for aircraft safety as well as for human safety.
Yes.
That was great talk. Thank you very much. So I have a question. You mentioned that your robot's like a snake.
Yes.
Do you study animals to find inspiration for your robots?
I don't study animals, no. It's just more of a it's kind of analyzing the current mobility methods that are used in industry right now with different types of robots. So you can have your walking robots, swimming robots that have been developed, and I'm somewhat analyzing these different types of mobility methods and combining them in some sort of way to make it more applicable to my project.
Yeah, perfect. Thank you. So Glixandrew, I'm sorry, that's a YouTube name, so I don't know if I've pronounced that right and where the split is. To what extent can we compare the human touch inspection with the robot assistance? What about when things need to be fixed?
So again, this is just the basic start of the project overall. I mean, to have a robot that would have an end effector that would be able to fix something or repair something, I think there's still a bit more time in order to reach that sort of goal. I think the main specific key point is how can we make a robot that's suitable enough to just move within the fuel tank, and then on top of that we would carry out research on what kind of end effectors you could add onto the robot itself.
Perfect, thank you. One final really quick question then, because we are almost at the end. Again, this is from Watling Academy through YouTube, so thank you, Watling Academy. You've lots of great engagement there today. What is your favourite thing about your job?
I think my favourite part of my job would be more of the physical aspect. So to be able to go see an aircraft and see the type of inspection tasks that are being carried out physically, and seeing it from a physical viewpoint rather than theory. And I think applying what you learn from a physical knowledge to a theoretical point of view, I think that's a very good combination to have. So that's why I enjoy fixing things and reading things together, so it helps.
Very cool. Thank you very much.
Thank you.
Great. Thanks, Manpreet, for answering the questions. And I'm sure there have been more questions and we couldn't have all picked them up, but our speakers will try to answer them over the next couple of days, and we will post them in a blog post on our homepage. So make sure to check that out. And as Jill said, we're nearly at the end of our session today, and time always flies by immediately fast during Soapbox Science event. It's fascinating. And I'd like to thank again all of our amazing speakers today and for the presentations they gave, as well as for the people who joined us online and listened and asked questions. And also to my fellow organizing committee members of all of their work leading up to the event, as well as now in the background. And a very special thank you for two people in the background, Sam and Katrina from the Open University, for their knowledge and technical support for our live broadcast today. Without your help, this wouldn't have been possible. So thanks a lot. I'd also like to invite you to join us for our second part of the Soapbox Science event this Saturday at 2 p.m. again live on YouTube and Facebook.